So let's start with the first question. What are these small molecules? Small molecules are difficult to define. I can define the macromolecules that we've been hearing about, genes, proteins, the repeating elements of nucleotides and amino acids. Small molecules are much more complex. Small molecules comprise the atoms, typically carbon, hydrogen, oxygen, nitrogen. They're bonded together. I give you one illustration on the slide in various ways in making different kinds of rings and substituents. If we can roll the first animation, I'll show you that, in fact, however, these structures are a bewildering array of different three-dimensional shapes. And it's this different shapes that's so key to allow them to interact with the many different proteins encoded by the genome. You're looking at some molecules, you're seeing the different kinds of shapes and even atoms, different atoms that I've mentioned. Having defined or looked at some of these small molecules, now we're going to ask, how do they modulate the proteins to which they bind? The first answer, of course, is that they do associate with the protein. They bind to the protein. The answer to my question fundamentally is going to be that, and the message that I want you to receive is that upon binding, these small molecules create a complex with a protein. And we should think about this complex as a completely new entity, a new entity that can be either inactive or overactive. Can we roll the next animation? What you're seeing here is the cellular protein calmodulin in blue. Plays a key role in a number of cellular functions. It does so by using a cleft that you can see. The cleft has now been occupied by the gold small molecule. And so in the process, we have a small molecule protein complex. You notice it has a very different shape. It is, in fact, in this case, inactive because that cleft is no longer available for its normal cellular function.